Hi, ladies and gentlemen. We are looking at notes 5.2 on angle relationships in polygons, and it's on the bottom of the previous page that we were looking at before, so that's page 3 right here. So let's do a reminder of what we discovered in class. So remember, we learned in class that in a triangle, we have 180 degrees for my interior angle. So these three interior angles will always add up to 180 degrees, okay? Now, if you remember, we figured out that two triangles are created when we have a quadrilateral, any type of quadrilateral. So the number of degrees that we have inside of a quadrilateral altogether is 180 times 2, or 360 degrees. So remember right here, we're going to say n equals 3, and the number of degrees is 180 degrees. Here we're going to say n equals 4, and we did 180 times 2. And then for the next one right here, if you remember, we figured out, oh, there's 3 triangles in a pentagon, so when n equals 5, we have to do 180 times 3, which is 540. Okay, and then when we had a hexagon, when n equals 6, we had 1, 2, 3, 4 triangles, so it would be 180 times 4, which is 720 degrees. So the question is, where are these numbers coming from? And you should have figured that out in your stations, but let's just double check right here. So this one right here, we did 180 times 1. To go from 3 to 1, we subtract 2. Right? And this one right here, our n was 4. To go from 4 sides to 2 triangles, we did 4 minus 2, which is 2. Okay? Here, our n was 5, and we had 3 triangles, so we did 5 minus 2, gives me 3 triangles right here. And then over here, we had 4 triangles when n was 6, so we did 6 minus 2 to give us 4. So, therefore, we can say right here that for our triangle, it's 180 times 1. For our quadrilateral, it's it's going to be 180 times 2, right? For our pentagon, it was 180 times 3. And then for our hexagon, it was 180 times 4. Okay? So essentially, all we're doing is we're taking our n right here, we're subtracting 2 from it to figure out how many triangles there were, and then we just multiply it by 180 because each triangle has 180 degrees in it. So this right here is my expression that I would use for the sum of any interior angles in any polygon. Okay, so let's go ahead and write that in here. So that means that we can say that the sum of all the interior angles of any polygon is going to be 180 times n minus 2. So how do I find one interior angle of a regular polygon? Well, first of all, what does it mean for a polygon to be regular? What that means is that all sides and angles are congruent. Okay, so I'm going to take 180, multiply it by n minus 2, and then divide that by n right here. So that's what I get for one interior angle, because if there's this many that it adds up to, I had to divide it by however many sides or however many angles there were altogether in the problem, okay? And then if you remember when we did our stations, we also figured out that the exterior angles of any polygon will always be 360 degrees. And if you remember, we actually measured all of our different polygons to see what we would get for our exterior angles, and our station told us, we discovered that it will always add up to 360 degrees. So let's go ahead and do some practice problems. Question number 1. Find the sum of the interior angles of a polygon with 22 sides. So this time I want to find the sum. And if I want to find the sum, I'm going to use the formula 180 times n minus 2. So I know right here that if the polygon has 22 sides, that n is 22. So I would do 180 times 22 minus 2, which is 180 times 20. So I know that my answer is going to be that it adds up to 3,600 degrees inside of my 22-sided polygon, my 22gon. Okay? Question number 2. Find the measure of an interior angle of a regular polygon with 10 sides. So let's find the sum first. So to find the sum, we're going to do 180 times n minus 2. And here we know that n is 10. So I would do 180 times 10 minus 2, which gives me 180 times 8 right here. And then we can go ahead and calculate what's 180 times 8. And we end up getting 1,440 degrees. Well, this is the sum. So how do I find the measure of one angle? Well, I know that there are 10 sides, which means that there are also 10 angles. So I can take the sum, which is 1,440, and divide it by however many angles there were, which is 10. So I know every angle on the inside is going to be 144 degrees. Okay? All right. Number 3. How many sides does a polygon have if the sum of its interior angles is 3,780? So if we know that there's a formula that says the sum is equal to 180 times n minus 2, and this time we don't know what n is. N is a mystery to us. But we know that the sum is 3,780. So I'm going to replace this sum with 3,780. So I'd say 3,780 is equal to 180 times n minus 2. Now it's just a regular equation that I have to solve. So I would do 3,780. When I distribute the 180, I get 180n. And then when I distribute the 180 to the negative 2, I get negative 360. I'm just going to rewrite this up here because I'm running out of room. So now I'm going to add 360 to both sides right here. And I end up getting 180n is equal to, and let's go ahead and add this together. So 3,780 plus 360 is equal to 4,140. Okay, now my last step is just to divide that by 180. And I get 23. So n equals 23. So how many sides does a polygon have? If the sum of its interior angles is 3,780, 23 sides. Let's double check to make sure this is true. If there's 23 sides, that means that there are going to be 21 triangles. So if there's 21 triangles, sorry, that's not what I meant to open up. If there are 21 triangles, each triangle is worth 180, you end up getting 3,780, which is exactly what I have here. So my answer is correct. Okay? All right, question number 4. Use 2 different methods to determine the measure of one interior angle of a 15-gon. So the first method is what we did in question number 2. I know that the sum is going to be equal to 180 times n minus 2. So I know right here that n is 15. Right? So I can just say that the sum is equal to 180 times 15 minus 2. So I end up getting 180 times 13. Okay? So when I go ahead and multiply 180 by 13, I end up getting 2,340. That's the sum. Okay? But now that I've figured out my sum, I have to figure out how much is in one interior angle, and this will only work if this is a regular 15-gon. If it's not regular, I can't assume that all the sides and all the angles are equal. Okay, so now let's figure out how much is in one. I just take 2,340, divide that by 15. So let's see what we get when we divide it by 15. We end up getting 156 degrees. So that's the answer. That's one method that I can use to figure this out. Okay, now another method that I can use is, remember when we have a polygon, this right here, if this was my interior angle, actually let's not do it that way. Let's do it like this. This right here, if this was my interior angle of my polygon, then this would have to be my exterior angle. And we know that the sum of the exterior angles add up to 360, right? So let's find one exterior angle. So how do I do that? I just divide 360 by 15, and when I do that, I end up getting 360 over 15, 24. So I know that one exterior angle is going to be equal to 24. Well, if my exterior angle is 24, how do I figure out what my interior angle is? Well, I just take 180 and subtract 24 from it because I know altogether this will make 180 degrees. So when I do 180 minus 24, I end up getting 156 degrees. So we have two different methods that we can use to figure out the measure of one interior angle of a 15-gon. Okay, and hopefully that makes sense. I will see you next time we have class. Have a great day.